chapter 12. We're going to talk about liquids, solids, and intermolecular forces. Chapter 11 was about gases, and now we're going to talk about the other two states of matter. Have you ever wondered why things taste the way they do? You know, why do some foods taste sweet and some are sour, and water doesn't really have much of a taste at all? Water tastes delicious? I'm happy for you. It tastes like just kind of nothing to me. I'm not a big fan of plain water.
It tastes like chlorine.
Tastes like chlorine. Yeah, sometimes you can taste the chlorine in the water. But most taste actually originates from interactions between molecules. The molecules in the food and specialized cells on your tongue. And they only recognize certain types of molecules. And you may have learned that there are different areas of your tongue that are better at tasting salty or sweet or bitter, etc. And that's because there's a greater concentration of those particular specialized cells. So we're going to look at the interaction between molecules. Coffee has a bitter taste, and it's that interaction between the molecules in coffee and the taste receptors on your tongue, and it's caused by intermolecular forces. Inter is a prefix that means between. Intermolecular. These are forces of attraction between different molecules. And these types of forces are very important. All physiological processes involve intermolecular forces at some level. There are also less specific intermolecular forces that exist between all molecules and atoms. The reason that water is a liquid at room temperature is due to intermolecular forces. If there were no intermolecular forces, everything would be a gas, and there'd be no planet, and there'd be no life, and it would just be a bunch of atoms zinging around in the gas state. Yeah, so I already did that. The physical state of any given sample of matter is going to depend on how strong those forces of attraction between molecules are compared to the amount of thermal energy at a given temperature. Atoms are in constant random motion. The atoms in a liquid are moving around relative to each other. I gave you an analogy earlier in the semester about students, and right now you guys are in the solid state. You're not moving relative to each other, and yet everyone's moving a little bit, right? Hopefully at least breathing. When you go into the liquid state, then you're milling about the classroom, and when class is over, you leave the classroom and everybody goes off in different directions and has absolutely no interaction with each other. So the thermal energy is related to this motion, and the motion opposes the forces of attraction. So if you have more motion, it can break those forces of attraction. If we have weak intermolecular forces relative to the thermal energy, then we're more likely to have that substance be a gas at that particular temperature. And if the intermolecular forces that hold the molecules or atoms together are strong, then it will be a liquid or a solid.